Hello everybody and welcome back. Root Beer here with question number 14 on the 2005 Gauss paper. The numbers on opposite sides of a die total 7. What is the sum of the numbers on the unseen faces of the two dice shown? Okay, so they do mean unseen faces. For a second when I read this, I thought it might be just the one below the 3 and below the 1, like the bottom faces, but they mean unseen faces. Dice have 6 sides, so we've got 3 faces for each of these dice that need to be seen. Okay. So I'm thinking there's a couple ways to do it, and one that I just noticed right now. One that I did notice is that we've got a dice has 1, 2, 3, 4, 5, or 6 on its sides, and you'll notice 1, 2, 3, 4, 5, and 6 are all shown. So the other faces that aren't shown, opposite this 3 is going to be a 4, opposite this 2 is a 5, and the 6 is a 1. Well, that's the numbers on this die. And the dice on the numbers on the second die that aren't shown are just the numbers on the first die. So if we just add up all these numbers, we'll be good to go. And I'm fairly certain the answer is 21. So that's one that I just noticed. But I'm not sure everyone noticed that. I don't think I would have noticed it if I hadn't just been counting them off in my head. So, there's a couple other ways we might want to do this. Okay, one way, which we're going to do right now, we're going to actually work out the individual sides that aren't seen, and then add them up. And this is, I think, a slower way to do it, but that's okay. So we have a 3 up here. I'm not going to put the dots. A 6 here and a 2 here. But then we can work out these unseen faces, the bottom and the 2 back faces. Okay. So we know that the numbers on opposite sides of the die total 7. So opposite this 6 should be a 1. Opposite this 2 should be a 5, and it might take us a moment to figure some of this out. Opposite this 3 should be a 4. And we can do the same with the other side, or the other dice. The other dice has 1, 5, and 4. 1, 5, and 4. So opposite this 4 should be a 3. Opposite this 1 should be a 6. And opposite this 5 should be a 2. So now we'll take these numbers, the unseen faces, the opposite side faces, and we add them up. 1 plus 2 plus 3 plus 4 plus 5 plus 6, and we get 21. Okay. Same sort of thing as the last one. We just didn't make the connection that the opposite ones on this side of the dice are the visible ones on this dice here, and that's fine. Another way that I think we could go about doing this. Each die, so here's another way to do it, but again, we still are going to get C. Each die has a 1, 2, 3, 4, 5, 6. So the sum of all faces on a die is 21. So the sum of the faces on both die 21 plus 21, 42. So this 42 is the sum of the seen faces and the unseen faces. Well, if we just want the unseen faces, that's going to be the total 42 minus the faces that we can see. And we can quickly add those up. So that's 42 minus 1 minus 4, minus 5, minus 3, minus 2, minus 6, and we once again get a 21. Okay, so that's 3 different ways we could do it. Recognize that each of the sides is used exactly once, so the second die is the unseen faces of the first die, and vice versa. Just individually work out those unseen faces, or avoid the unseen faces altogether, and take a look at the sums of the dice as a whole, and concentrate on what we do know, which is the seen phases. So that's 3 different ways, and that's more than you could ever hope for. Hopefully you guys use one of these ways. If you got a 4th way, I'd love to hear it in the comments. But other than that, we're going to move on to the next question. So thanks for watching. I'll see you next time.